Hello, this is Heading Tian. In this video, we will learn Chapter 2.3, Venn diagrams and set operations. The first part, let's learn about the Venn diagram. The Venn diagram shows the visual relationship among the sets. The U is the universal set, which contains all the elements being considered in a problem. And A or other B or C are other subsets of the U. For example, if I have a universal set U, it's a capitalized U. Okay. U equals 2, 3, 4, 5. And A equals 2, 3. So U is contain all the elements in the problem. Maybe this question, I say all the elements is the universal set contains 2, 3, 4, 5. And the subset A is 2, 3. So here is my A is 2 and 3. So other elements should be here, 4, 5. Okay, let's continue to see number 2. Understand the basic ideas of Venn diagram. The set of all elements in the universal set are not in set A is called the complement of set A, and is symbolized by the complement of A with this symbol. Use the Venn diagram to determine the example, to determine each of the following sets. So here you see a Venn diagram, and U is universal set. It contains every element, including 1, 5, 6, 7, 9. So universal sets equals the set 1, 5, 6, 7, 9. The set A is here. Okay. Include the elements inside the A is 1, 5, 6. 1, 5, 6. The set of elements in the U that are not in A. So the elements is still in the universal set U, but it's not in A. So it's here. Is the complement of set A is 7, 9. Okay, let's move on. Number 3. Use Venn diagram to visualize relationship between two sets, representing two sets in a Venn diagram. So there are 4 kinds of relationships. The first relationship is disjoint set. So in the universal set, the subset A and subset B has nothing in common. That means no element in common are called disjoint set. So the set A and B are disjoint set. Second relationship is proper subset. We learned this proper subset last class. If the set A is proper set of set B, the relationship is shown in the Venn diagram. That means all the elements in A, in here, is in B, but A is not equal B. So all the element here is in B, but A is not equal B. Okay, next relationship is equal set. If A equal B, then set A contains exactly the same elements as set B. They are equal. Next relationship, we have a lot of problems about the relationship for set with some common elements. That means in mathematics, the word sum means there exists at least one. So if set A and set B have at least one element in common, then the circle representing the set must overlap. That means if A and B are in common, have some elements in common, that means A and B must overlap or intersect. The set of elements common to both set A and B is called the intersection of set A and B, and is symbolized by A intersects B. That means the dark blue area is the intersection of A and B, and this one we called A intersect B. In the example, let's see the example. Use the Venn diagram to determine each of the following set. Here is the Venn diagram, and find U, the universal diagram. Oh, sorry, universal set, U. The universal set include everything. That means everything here include A, B, C, D, E, F, G. A, B, C, D, E, F, G. The set B equals, set B is here, equals D and E. D, E. Next one, the set of elements in A, but not B. So the element is in A, but not B. This area is in B, so I need to only count the number here without counting the number here, the element here. So this set include A, B, and C without the element D. Next one, the set of elements in U that are not in B. So it's in U. That means all the elements, universal sets, all the elements, but not in B. That means the complement of set B equals, so except this area, I can count everything. That means A, B, C, F, G. Remember, use a comma to separate the elements. Use the comma. Next one is the set of elements in both A and B. So in the Venn diagram, we see if the element in both A and B, that means should be in the overlap part. That's in the intersection of A and B. We only have one element, which is D. And you can also use the region to express this. For example, U universal set is 1, 2, 3, 4, and for this 4 region. And number 2, B is D and E. I can say region 1, region 2, and region 3. Number 3, all the elements in A but not in B. That is region 1. Number D, the set of the complement of set B is 1 and 4, right? Is this part and this part. This is the complementary a complement of set B. Next one, E. The set of elements in both A and B, that's region 2. Okay, let's go on to next part, is part 4. Find the complement of a set. The complement of set A, we already talked about this. We said is complement of set A. We denote by this. Is the set of all elements in the universal set that are not in A. We can express it in the set builder notation, which is the complement of set A is all the elements X such that X is an element of U universal set, and X is not an element of A. That means in the Venn diagram, this diagram, you will see the blue area is the complement of set A. Let's go on to the next example. Let set universal set equals 1, 2, 3, 4, 5, 6, 7, 8, 9. And A is 1, 3, 4, 7. Find the complement of set A. You can use the Venn diagram, and you can also just cross out the elements in A from the universal set, which means A is 1, 3, 4, 7. Cross out 1, 3, 4, 7. So rest of them are the complement of set A, which is 2, 5, 6, 8, 9. Okay, let's move on to part 5. Find the intersection of two sets. The intersection, we already talked about that. That means, so in this Venn diagram, the intersection part is the blue, dark blue area. So we write that into this notation. A intersects B. The set of elements common to both A and B. The site builder notation is A intersects B equals X, such that X is in A and X is in B. So let's see the example. The elements common to this set and this set are 8 and 10, because 8 and 10 are common in these two sets. So the intersection of these two sets is the set 8, 10, 8, 10. We can use Venn diagram to express it. Number B, the set 1, 3, 5, 7, 9, and 2, 4, 6, 8. They have no element in common. That means the intersection is 5, the empty set. So you just use 5 to say the intersection of these two sets is empty. Next one, there are no elements in 5, the empty set. This means that there can be no elements belonging to both this set and the empty set. Therefore, if the intersection of the set 1, 3, 5, 7, 9 and the empty set is empty, nothing in the intersection of these two. Okay, let's move on to next part 6. Find the union of two sets. The union means the set A and B. The union of set A and B, written A union B, is a set of elements that are member of set A or set B or both. That means if I use a Venn diagram to express A and B, that means all the elements in this shaded area So let's use the set builder notation express that. A union B is X, all the element X, such that A is in A or X is in A or X is in B. That means we need to add all the elements. We put all the elements together from A and B. And remember, there's no repetition. For example, A equals 1, 2, 3. B equals 2, 3, 4. And the intersection of A and B is 2 and 3, and A is 1, 2, 3. B is 4. Because A, B. So A is 1, 2, 3. B is 2, 3, 4. So what's the A union B? I should put all of these elements together, right? But without the repetition, which is 1, 2. Do I need to add another 2 here? Because add them together? No, because we already have 1. So no repetition. 3, 4. So I add them together. Okay, let's move on to the example. Find each of the following unions. So first one, A. The set 7, 8, 9, 10, 11, and the set 6, 8, 10, 12. So the union of these two sets is 6, 7, 8, 9, 10, 11, 12. Even you see they have something in common. We just keep one. Next one is one. The first set is 1, 3, 5, 7, 9. Second set 2, 4, 6, 8. The union is 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh. Okay, so next one, this one and this one. So the union should be 1, 3, 5, 7, 9. Just the first set, because there's nothing in the empty set. So the union of any set and the empty set is the set of itself. Okay, let's move on. Oh, here, the empty set in the intersection and union. This one is important. For any set A, the first one, A intersect the empty set is empty set phi. Second one, A, do I say something wrong? I will say that again. Okay, the first one, A intersects phi equals phi because they have nothing in common. Second one, A union phi equals A because nothing here in the empty set. So the union should just be A. Next one, perform operations with sets. Performing set operations always begin with performing any operations inside parentheses. So for example, finding A union B, and you see here is a complement. So this is a complement of the set A union B. So do the inside parentheses operation first. For example, I just draw a Venn diagram, A and B, the union of A and B here. So we are looking for the complement universal set. We are looking this. So first we find the union and then find the complement. And next one, finding the complement of set A intersect complement of set B. So first we find the complement of A, and then second step we find the complement of set B. And next step we do what? We do the intersection. A complement of set A intersects complement of set B. Okay, here is the example. The universal set is 1 through 10. A is 1, 3, 7, 9. B is a set 3, 7, 8, 10. Find A. The complement of A union B. So what's the first step? Find the operation inside the parentheses. So A union B, let's, if I have some space here. So A union B equals 1, 3, 7, 8, 9, 10. The complement of A union B, I just cross out all of these numbers from the universal set. 1, 3, 7, 8, 9, 10. 1, 3, 7, 8, 9, 10. I have 2, 4, 5, 6 left. Yes, this is the way how I find this. And next part, I just erase this. Clean some space. So find this. First, I need to find the complement of set A equals A is 1, 3, 7, 9. 1, 3, 7, 9, which is 2, 4, 5, 6, 8, 10. What is the complement of set B? So B is 3, 7, 8, 10. So 3, 7, 8, 10. I have 1, 2, 4, 5, 6, 9 left. So find the intersection of these two sets. So what's in common? 2, 4, 5, 6. I think that's it. So the intersection is 2, 4, 5, 6. Okay, let's move on to next part. 8. Determine set involving set operations from Venn diagram. Use the diagram to determine each of the following sets. Okay, here we have a Venn diagram and some operations. So let's see. Set A union set B. That means everything in here, right? So we just list all the elements in the raster form, or I can say A is in the region 1, 2, and 3. So B, so complements of set A union B. So we already know the A union B from the part A. So the complement of this area is only the part 4. Next one, C. A intersects B is easy one, is region 2. D, the complement of the set A intersects B. That means A intersects B is here. So everything outside except the dark blue area. That means, oh, it's so messy here. Okay, that means it's area 1, 3, and 4. Next one, number E. The complement of A intersects B. So the complement of A, find complement of A, intersects B. So the B is, let's use different color. If first I just shade the complement of area A with blue. This is a complement of A, and use green to find the B. So find the intersection. This is B, and this part is the intersection. That means only the part 3. Next question, F. A union the complement of set B. Let's clean the Venn diagram. A, use the green, use the blue color. So A, union the complement of B. Complement of B is this area. So be careful when you draw your Venn diagram. So everything, I need to count everything because this is the union. That means everything is 1, 2, and 4, except the area 3. And you can also use the raster form to list all the elements in these regions. Okay, let's clean up. Okay, let's move on to next part. Part 9, understand the meaning of and, or. The word or refers to the union set. That means A union B. If I draw a Venn diagram, okay, let's draw a Venn diagram. It's A and B. So, or if I say A, maybe the element X is in A or B, or I can say A union B. They are the same. That means the X could be here, all of this area. Let's see, second one is and. The word and refers to the intersection of A union, A intersect B. That means the X must be here in the intersection area. Let's see the example. So when you see or and, that represent different meaning. The or means the union, and means intersection. Okay, let's see the example. In the example, U is the set of U.S. Hispanics. S represents the set of U.S. Hispanics who speak Spanish at home. E set is the set of U.S. Hispanic who speak English at home. So S speaks Spanish, E speak English. They are all Hispanic. They are all the subset of Hispanics. Here is the pie chart. It shows people who speak Spanish, speak English, and speak both. And how to use a Venn diagram to express this? This circle is Spanish. This is speak English, and in the intersection part is Hispanics who speak both Spanish and English. So let's see the meaning of this part. Let's start from here. So Spanish or English. So if I say the Hispanics who speak Spanish or English, that means as union E. That means all of these. That means I need to add all the elements together. So they give us the percentage. We can add add them together. That is 43% plus 23% plus 32%, which is 98% who speak Spanish or English. Let's see this part. So 43 speaks Spanish and not English. That is part 1. So this means only speak Spanish as represents Spanish, but and this is and the people don't speak English. So Spanish part and deduct this part. We have a region 1 left. Let's move on to next part is 32% speak English and not Spanish. So speak English and deduct. So subtract this area is area 3 is 32%. That means you see is E intersect the complement of S. Let's move on to next place. 23 speak Spanish and English. That means the intersection here. S intersect E. Okay, here 23% plus 32% equals 52% speak English. So this region 2 and 3 speak English. This includes people who speak only English or people who speak Spanish and English. Is region 2 and region 3. Next part, 43 and 23 plus 23 equals 66 speak Spanish. This includes people who speak only Spanish or people speak both English and Spanish. So you will find we have a lot of questions like this Venn diagram and let you to explain what did you see. Okay, let's see next. Use the formula for n of A union B. That's the cardinal number of the union of two finite sets. The n of A means number of elements in A. For example, A equals the set 1, 2, 5, 7, 8. Then the number of A is 5, the cardinal number. So if I have A equals okay, 2, 2, 3, 3. What's the cardinal number of A? N of A is 2. Even we have 4 elements in it, but the repetition make the cardinal number of A is 2. So let's see this. The number of A union B equals n of A plus n of B minus n of A intersects n of B. So what's the meaning of that? Let's draw a Venn diagram. I have A and B. A set is 1, 2, 4. B is 2, 4, 5. So the intersection is 2 and 4. 2 and 4. 4, 2. It doesn't matter. The order doesn't matter. So 1, 5. Here is A, and this circle is B. The union of A union B. Remember that the union of the set, we add them together. Come back. Okay. Okay. So the union of A and B, they can't. We don't need to put the repetition elements in it. Repeated elements in it, which is 1, 2, 4, 5. Even we see we have 2 here, 2 here. We don't put 2 2's here. That means, okay, so the number of A, n of A equals 3. N of B also equals 3. And the n of A union B, that equals n of A plus n of B minus the intersection n of A intersects B. Because 3 plus 3, we add them together. We add 2 times the in common elements. We must I'm sorry. I think I made a mistake. Okay, let's see. So A union B is 1, 2, 4, 5. And so it's right. I didn't make a mistake, I think. So that's right. So what's in common is 2 and 4. They are in the intersection part. So if I have 3 plus 3, totally they are 6. But from here, this part, we already know the union of A and B is 1, 2, 3, 4. Also 1, 4. Sorry, 1, 2, 4, 5 is 4. The cardinal number is 4. So we must use the number n of A plus n of B minus intersection of A and B, which is 2, which is this area is 4 and 2, or 2 and 4, it doesn't matter, which is 6 minus 2, which is 4. So remember, this is a formula to find the cardinal number of A union B. It equals to n of A plus n of B minus the number of intersection in the intersection part. Okay, let's see the example. Let me clean this. It's in the example, according to the factmonster.com, among the US presidents in the White House, 26 had dogs, 11 had cats, and 9 had both dogs and cats. So can you make a diagram? Venn diagram. This one is 26 has dogs. I put D here. And 11 has cats. I use C here. And both has dogs and cats. We have 9. That's the intersection here. So how many US presidents had dog or cats in the White House? So let's set A be the family, the president has dogs, and B is cats. So we are looking for dogs or cats. That means it's looking for the number of A union B, because do you still remember union is OR? So equals, okay, here, I don't need to write, is n of A plus n of B minus n of A intersects B. So we already know n of A is n of A is 26. So 26 plus n of B is 11, and minus both, minus 9. What's this? 28. So so the US presidents had dogs or cats in the White House is 29. So this video is about the chapter 2.3. If you have any question, please let me know via email or please ask me in the tutoring session. Okay, have a good day.